Okay. Good afternoon. Good evening. This is chemistry class. This chemistry class, the first chemistry class with you in TNBC 2022 batch. Welcome to my chemistry class. Today's topics is uh, 10BC, class 10BC, subject chemistry, chapter 16, topics acids, alkalis and titrations. We have seen here picture. Have you seen these things? This picture. Here, what is this? Diet contains citric acid. What is this? This fruit's name? What is the name? This fruit's name?
Orange.
Orange. Orange contains citric acid. This is weak acid. Okay. With this sour is sour taste. So today we will discuss about what about today's, and we feel bitter taste in soap. Because it's contain what contains. Do you know? Here look, acid range from the extremely dangerous. This acid and protective clothing need to clean up space. So strong acid, weak acid. This acid we can take because these are weak acid, and don't take. This is dangerous. We need to put clothing, protective clothing, to clean up space. So this is strong acid. So today's topic is this acid, base, and alkalis, and finally titrations. Acid are those which provide H plus ions when they are dissolved in water. When this substance are dissolved in water, they produce H plus ion, like HCl produce H plus ion, nitric acid produce H plus ion, and nitrate ion H plus ion produce. Sulfuric acid are two hydrogen ion in. Okay, so this is acid. This is also, these are strong acid. They are fully ionized. This is acid, weak acetic acid. This is weak acid, partially ionized. This is equilibrium sign. Acetic acid, formic acid, these are weak acid. Strong acid, a strong acid is completely ionized in aqueous solution. Example, strong acid are hydrochloric acid, nitric acid, sulfuric acid. Look, HCl completely ionized. This is arrow direction is one direction. This nitric acid completely ionized, sulfuric acid completely ionized. And weak acid is only partially ionized in aqueous solution, like ethanoic acid. Here it is partially ionized. This look, some less than 1% ethanoic molecule will ionize in this reversible reaction. 1% less than. So it is weak acid, here partially ionized, like ethanoic acid. Now alkalis are those which provide hydroxide ions when they are dissolved in water in aqueous solution. Sodium hydroxide produce H plus hydroxide ion, potassium hydroxide produce hydroxide ion, calcium hydroxide produce hydroxide ions. Alkalis can be also strong and weak. Those which ionize completely are strong alkali. Those which doesn't ionize completely are weak alkalis. This strongly fully ionized, so it is strong alkalis: sodium hydroxide, potassium hydroxide, calcium hydroxide. This ammonia, then ammonium hydroxide, this partial ionized, equilibrium sign. So this is weak acid, weak alkalis. Okay, we can measure by acidity range. Acid range is about 0 to about 14. 7 is neutral, less than 7 is acidic, and less than greater than 7 is alkaline. The smallest the number, the stronger the acid. If smallest number like 1.0 is strongest acid, like 7 is weak acid. The larger number, the larger the number, the stronger the alkali. Like pH 14 stronger alkali, 13, but 7, not 8, 9, this is weaker alkali. The pH and indicators. pH scale range. pH scale range from about 0 to 14 and tells you how acidic, how alkaline a solution is. This is the pH scale ranges. Have you seen? This is pH scale ranges. This is about 0 to about 14, not 0. If you say pH 0, what will be? Nothing acid. It is about 0, like 0.001. It's like something, it will be not actually 0. About 0 to about 14. Okay, 0 to 14. So increasingly acidic here, like 7, 6, 5, 4, 3. The acidity in stock. This is strongly acidic. This is 4 to 6, 4, 5, 6. This weakly acidic. 7 neutral, and 8, 9, 10 is increasingly alkaline. 8, 9, 10 this weakly alkaline. 11, 14, 12, 13, 14 this is strongly alkaline. Look at hydrochloric acid, strong acid. Vinegar, weakly acidic. Water, sodium chloride is neutral. Ammonium solution is weakly alkaline. Sodium hydroxide solution is strongly alkaline. Okay, we have just seen pH scale. The pH scale from 0 to 14 is measure of the acidity or alkalinity of a solution and can be measured using universal indicator or pH probe. A solution with pH is 7 is neutral. Aqueous solution of acid have pH values less than 7. Aqueous solution of alkalis have pH values greater than 7. Okay, universal indicator, red color. This pH is 1 to pH red color indicators. Universal indicator colors. Red color when it show pH 1 to strong acid. Orange color yellow, pH 3 to 6 weak acid. Green pH 7 neutral. Blue pH 10 to 8 to 11 weak alkali, and purple 12 to 14 this is strong alkali. Universal indicator. We can classify substance as strongly acidic or alkaline, or weakly acidic or weakly alkaline based on their pH. Remember, when writing pH, it is small p and big H. You write pH when this one you write small letter p and capital letter H, the symbol for hydrogen. Okay, this strongly acidic about 0 to 3, hydrochloric acid. Weakly acidic 4 to 7, ethanoic acid, vinegar. Neutral 7, sodium chloride and water. Very alkaline, ammonia. Weakly alkaline 8 to 10, ammonia, and strongly alkaline 11 to 14 is sodium hydroxide. Do you know what is indicator? You know this. I taught you from. I am teaching you from class 8. Not 1. 6 BC British curriculum. Wow. So what is indicator? You know about things.
Yes, sir.
What is indicator?
Litmus paper.
Huh? Indicator is a substance which changing its color show either acidic solution or alkaline solution or neutral. It's by changing its
litmus paper.
Litmus paper is an example. Phenolphthalein, methyl orange is indicator. Okay, any substance that has different colors depending on the pH can be used as indicator. Some common indicator and their color in acidic and alkaline solutions are litmus paper. In acid solution, like when I dissolve litmus paper in acid, its color will be shown red. When alkali, its color will be turned into blue. And methyl orange, this is the indicator. When we put in acid solution, its color will be red, and in alkaline solution, its color will be yellow. Phenolphthalein indicator, in acid solution, its color is colorless, and in alkali, its color is pink. Universal indicator, in acidic solution, its color is red, and in alkali solution, its color is blue. So indicator is a substance which changing its color show either acid or base or neutral. Look, universal indicator is made from mixture of indicators which change color in a gradual way over a range of pH. It changes color gradually, like red, green, purple, yellow. It's gradually changes color over the range of pH values. It can be used as a solution or as paper. Here solution or paper. The most common form is known as full range universal indicator. It changes through a variety of color from pH 1 right up to pH 14, but it isn't very accurate. Okay, it will not be accurate. The color of the paper or solution is checked against a chart to find the pH. A universal indicator is a pH indicator made of a solution of several compounds that exhibits several smooth color changes over a wide range of pH values to indicate the acidity or alkalinity of a solution. Alkalinity. Okay, universal indicator is a pH indicator made of solution of several compounds that show exhibit several smooth color changes over a range of pH values to indicate the acidity or alkalinity of solution. Now we watch a video about let's watch a video about universal indicator. Oh, don't go. This. Okay, we watch this video, and I am giving this ear heading.
The demonstration you are about to see has safety risks. Because of these risks, I'm wearing closed-toed shoes and safety goggles. This demonstration should only be done by a trained professional and should not be tried at home. Skin contact with dry ice can cause tissue freezing, resulting in damage to your skin. Thus, direct skin contact with dry ice should be avoided. Hi, I'm Casey. I'm a chemistry major at James Madison University. The demonstration I'll be doing today is called Dry Ice and Universal Indicator. So in my flask here, I'm going to add some dilute NaOH. And as we know, sodium hydroxide is a base, and so this solution is basic. And just so there's more solution in the flask, I'm going to add some more. Next, I'm going to add some universal indicator. Universal indicator is a combination of 4 indicators so that it has a pH range from 4 to 10. And the colors of it are right here. So as I'm adding this, you can see that it's turning purple. So we're in the basic range of the scale. Make sure we're swirled properly. Next, I'm going to add some dry ice. Dry ice is the solid form of carbon dioxide. It is negative 78 degrees Celsius, and it sublimes at room temperature. And subliming is when it goes from a solid to a gas. And so right now it's subliming and gas is coming out of the top, as we can see, but also some of the carbon dioxide is dissolving in the water and forming carbonic acid. And carbonic acid is going to lower the pH, and we should see color changes as the pH lowers. So it looks like we're starting to go blue, and then we should be able to see green and then yellow. Looks like we're starting to go green. And we are slowly going to yellow, it looks like. Looks like we're at yellow, so we're down to about a pH of about 6 or so. This is Casey at James Madison University. Thank you for watching.
In this video, at first there is add NaOH, that means sodium hydroxide. It was strong acid, strong alkali. So at first its color was color. When universal indicator was added, its colors become blue color, and when then add solid carbon dioxide, this is ice like, and then it become it form carbonic acid, which is weak acid, and its color turn orange, yellow, green. This is pH 7 to 6, 5 to 6 like this. So acidity decreases and changes color. Universal indicators. So universal indicators changes color from purple, then green, orange green, then yellow, then red, orange, finally red. This way change. Okay, reaction acids with bases and alkalis. Reaction acids with bases and alkalis. Metal oxides such as copper oxide and magnesium oxide are bases. Metal oxide are bases, like sodium oxide, sodium Na2, or sodium oxide. Metal oxide like group 1 are metal, their oxide are metal oxide. Group 2 are metal, their oxide are metal oxide. Metal oxide are bases. When metal oxide react with acid like hot sulfuric acid in a neutralization reaction, so here neutralization reaction occur because copper oxide is alkali and acid is sulfuric acid is acid. Here is a neutralization reaction occur and produce salt and water. Like copper oxide is base, sulfuric acid salt. Copper oxide is base, metal oxide, and sulfuric acid form salt and water. Arya, take an screenshot today's class here attendance.
Okay, sir. Sir, done.
Okay, thank you. Okay, copper oxide is ionic compound. Why this copper oxide is ionic compound? Can you say anyone? Why do copper 2 oxide is ionic compound? Why do copper 2 oxide is ionic compound? Can you say anyone? Why do copper 2 oxide is ionic compound?
Assalamualaikum sir. Sir,
Why?
আমার attendance sir, screenshot টা sir.
অ্যাটেন্ডেন্স
Yes, sir.
আচ্ছা তোমারটা দিয়ে দিব ম্যানুয়ালি দিয়ে দিব না আচ্ছা copper to oxide is ionic compound because copper is metal and oxide is oxygen is non-metal. Okay, it's containing oxygen ion, and what has happened in this reaction is that H plus ions from the acid combined with O2 ions from the base to form water ions. So copper to oxide is an ionic compound containing the O2 minus ion, and what has happened in this reaction? Ionic compound here is contain O2 ion. Copper to oxide contain O2 ion, oxygen ion, and in this reaction that H plus ion from the acid have combined with the O2 minus ion from the base to form water molecules. So here or oxygen 2 minus come from base and hydrogen come from acid combinedly form water. And metal and this negative sulfate form salt. What is this? Yeah. Okay, metals above hydrogen react with acid to produce metal, salt, and hydrogen. Hydrochloric acid and metal from metal, chloride, salt, and hydrogen. Nitric acid and metal not needed. Sulfuric acid metal from metal, sulfate, and hydrogen. Only nitric acid can react with copper. Okay. Metal oxide when form metal oxide means base when react with acid form salt and water. Here water will form and salt. This is the base and acid form salt and water. Base and acid form salt and water. Okay, metal carbonate. When metal carbonate react with acid, metal carbonate like calcium carbonate, magnesium carbonate, ferrous carbonate form react with acid form which thing form? Metal carbonate when react with acid form metal, salt, water, and carbon dioxide. There are three products are formed when metal carbonate react with acid. These are salt, water, and carbon dioxide. When metal carbonate like calcium carbonate react with acid form calcium chloride, salt, water, and carbon dioxide. When metal carbonate magnesium carbonate react with acid form magnesium sulfate, water, and carbon dioxide, so on. Okay, next class where I have there is a class physically class on campus class. Do you know when will be held this class?
Thursday. Yes, sir.
Thursday. Okay, Thursday I'll take you a chemistry lab. I'll show some demonstration, acid, base, and alkali, and I also show titration. Okay, this chemistry topics titration. What is titration? Okay, do you know what is the name this one name this apparatus name? What is the name this apparatus?
Test tube.
Say another one. This one test tube. So what?
Conseil flux.
Huh? This one name is test tube. This one name test tube. What is the name? This one. This apparatus name?
Conical flux.
Excellent. Conical flux. Okay. Conical flux. I do titration conical flux, and here I'll put stand. I took this here burette. I use burette, like yeah. This button. This is the burette. And also I use pipette there, like pipette like this. Titration here. What is called titration? Do you know? Titration is a process by which we find out the concentration of unknown concentration of a substance, which concentration is unknown by known concentration substance. Look, this is titration. At first, what we'll do here, titration is versus carry out titration acid versus alkali. Here, this is the pipette. Look at pipette. This is a beaker. Measure out 25 cubic centimeter of hydrochloric acid using pipette. Okay, pipette. This is a pipette. This one is pipette, like pipette. Yeah. It is not draw properly. This okay, I show this pipette is this how much 25 cubic centimeter hydrochloric acid. Then it transferred into conical flux. What is this? And fill burette with sodium hydroxide solution. Here sodium hydroxide solution is from another beaker. Sodium hydroxide is taken here, burette. In this burette it prepare. Now add. So we have found it that in a conical flux there is a hydrochloric acid. In a burette there is a sodium hydroxide. So in conical flux is acid, hydrochloric acid, and burette in contain sodium hydroxide. Add a few drops of phenolphthalein indicator. Okay, so in this solution phenolphthalein indicator is has been added. Phenolphthalein indicator is added. So here which solution is contained? Do you know? In conical flux,
Hydrochloric acid.
so what will be color of phenolphthalein here? In acid, what is the color of phenolphthalein in acid?
Colorless.
Yes, thank you. Excellent. Colorless. We have seen this indicator. Look, phenolphthalein color in acid is colorless. Colorless. Phenolphthalein in acid medium, its color is colorless. Now here acid sodium hydroxide is added, being added until indicator changes color from burette and it's turned into color purple. So its color pink purple color, pink color, pale pink color turn. So permanent pale pink color turn. So it's become its indicator changes color and show it is now base. So this way indicator changing its color show acid and base. Okay, we can calculate how much acid or burette is from burette reading. We can calculate how much sodium hydroxide was added. At the beginning, its reading was, what's reading? Reading was this 2 minus ek থেকে 1 1 point is lower from 2. So what is this? So
2.1.
2.1. Now it changes koto minus. Now it's become 22.
No, sir.
22. This is 24. 22.
23 point.
Something. So
Yes, sir. Something.
how much was added? How much sodium hydroxide was added? Like it is not clear, but I should say this is 2, now like 22. So how much added? How much sodium hydroxide was added? Like at the beginning it was 2 cubic centimeter. Final reading
Yes,
was
sir.
like 22 cubic centimeter. So how much sodium hydroxide was added? How much sodium hydroxide was added? 20
20.
cubic centimeter. Okay, so I'll show this thing in the chemistry lab next class. Okay, you must present. You should present this class. Okay, everyone should unmute and give answer my question. Okay, unmute. Have you unmuted? Okay.
Yes, sir.
What is indicator? What is indicator?
Any substance that has colors depending on the pH can be used as an indicator.
Again say, Satmam maybe say what is indicator?
Any substance that has different colors depending on the pH can be used as an indicator.
Yes, excellent. Okay, what is the color of methyl orange in alkaline solution?
Yellow.
Yellow, good, excellent. Okay, what are the product formed when calcium carbonate react with hydrochloric acid? 3 products. What will be? What are the products names? Okay, 3 products. One is salt, water, and carbon dioxide. What will be salt name? Okay, less than 1 minute remaining. Thank you for joining today's class. Okay, thank you.
Assalamualaikum.